Hello. In honor of and in preparation for a presentation we have coming up as part of NASAR SARCon 2025, coming up in a couple days, I wanted to do a video for ADIAT that is going back to the basics. So a lot of the videos we put up on here get way in the weeds of talking about what's going on behind the curtain with ADIAT, with some of these algorithms and kind of some of the inner workings of the application itself. This video is going to be a little different. We're just going to approach this as if we are a brand new user coming into ADIAT for the first time. And we're going to talk about the process for deciding what algorithm to use, what parameters to use, and what the expected outputs will be. I promise we're going to spend the vast majority of our time in ADIAT itself today. And really the only slide we're going to reference is this one, which is our decision tree for deciding which algorithm to use depending on the scenario and the image set you have available. So with that, let's go ahead and jump on over to ADIAT. All right, we are in ADIAT now. Our user has gone to the Texar website and downloaded the latest version of ADIAT, in this case version 1.6.0, and they are ready to start using the application. Let's actually start by looking at our decision tree. So what we're going through here is determining which of the 8 algorithms available in ADIAT makes the most sense for your particular circumstances. So we'll start with a simple use case. This is not thermal imagery. Are we going to be exclusively looking for people? No. So we're over here. Are we looking for a specific color? Let's say we are. Let's say we know what the missing person was wearing, and we can start by looking specifically for those colors. Do you want to directly control the color range? Let's go ahead and say yes for now, but we'll explore both of these in a moment. Do you specifically prefer RGB over, well, do you specifically prefer RGB? Most times the answers could be no. So let's go ahead and use the new color range variant, which is the HSV color range algorithm. So back over in ADIAT, we're going to go ahead and set that to the algorithm selector to color range HSV, and we're going to go ahead and pick a color. So let's say we know the person was wearing a light blue shirt, so we can go ahead and select light blue here. We'll talk about how we decide what color to pick here in a moment, but then we set our 3 parameters. So as you may recall from the previous video, hue, if we're looking at our color picker, is basically going across here. Saturation is going up and down, and value is over here controlling the brightness. So let's go ahead and give it a hue range of 25. This is on a scale of 0 to 179. Saturation value are on a scale of 0 to 257. Sorry, 255. So let's go ahead and leave that at 50 and value at 50 for now. Go ahead and view the range. This shows us what is within the colors that we are going to be considering a match. So right now it's basically the square here. If we want to broaden that a bit, let's change this from 100 and this to 100. And we can see how that expands. So I'm comfortable with that color set. Let's go ahead and select our images. So we select the input image folder. This is all the images that the drone has collected, and it is going to be the input for our algorithm. So let's go ahead. I have some test data sets set up already for this. We select the one particular data set, and we select our output folder. So what ADIAT does, it looks through the images, it runs them through the algorithm, and then it saves augmented versions of those images in the output folder with the areas of interest highlighted. Coming down to our parameters here, we have our min object area. That's the minimum size of the object on the screen, in the image, that something must meet before it is considered to be an anomaly or something that is an area of interest. There's a couple of factors that impact how you want to set the min object area. One is the size of the image, so the resolution of the camera taking the image. If you have something like a 48 megapixel camera, like a Mavic 3T or whatever other kind of drone with a 48 or higher megapixel camera, you probably want to set that min object area somewhere in the 10 to 20 range. Also, if we're using one of the algorithms that's specifically looking for larger targets, so either the person detector or something that tends to return a lot of false positives just by the nature of how the algorithm works, then we may want to increase that min object area as well. For this, I'm just going to go ahead and set it to 10. I am not going to set a max object area. That's there to allow us to cut down on the false positives we see. So we don't want the algorithm identifying entire building saying it's an area of interest. We want it looking for something smaller than that so we can limit the maximum size of the object that we're looking for. Object identifier color, that's just the circle that it's going to put on the augmented image for us so we can identify our areas of interest. Max processes, this is going to come down to the hardware that you have available, the system you have available, and how many cores the CPU has, and a couple other factors like that. 10's a good baseline place to start, but you can just move that up and down and kind of track how performance goes for you. And if it's maxing out the computer, you can back off a little bit. If things are not running as fast as you hope, you can increase max processes up to 12 or 14 or whatever sounds good, and monitor the results. I'm not going to use R2 advanced features right now. K means clustering, is used to simplify images, for lack of a better term. We're basically eliminating most of the colors and grouping like pixels by color in the image. And then histogram normalization is about trying to normalize the exposure across all the images in the image set so that they have consistent lighting conditions, making it easier for us to compare them apples to apples as we do our analysis. So we have all of our parameters set for our first run here, our color range HSV color detector. Let's go ahead and hit start. And this will kick off, and you see it is going through these images. There's 158 in this image set. It identified 49 with areas of interest. It ran them in 5.76 seconds. If we go over to the viewer now, it pops up here and we see some information. We have the image name up here. We can toggle this overlay on and off, and this just gives us kind of that situational awareness of knowing which direction is north in the image, and gives us a rough scale so that we understand that something on the ground is this 10 feet wide or 1 foot wide. As we zoom in, you see that changes as well. We have some exports up here. We'll talk about those when we do a subsequent run here. We have the ability to show and hide images. So either using this toggle down here, we can show or hide an image, or we have keyboard shortcuts to do it as well, and all that is documented in the user guide. So if you're going through and you see an image that is clearly a false positive, you can go ahead and hide it, and that'll make it so the next time you go through the images, it skips that one, as well as removes it from the various exports that we run up here. You do have the ability to toggle skip hidden off, and it will go ahead and show you those, and as you go from one image to the next, it won't bypass the skipped ones. We also have our image count up here, and then the main area here. So we have obviously the full-size image, or the image scaled to fit the screen, where we can see our areas of interest have been highlighted. Over on the right side, we have our areas of interest thumbnails, where the XY coordinates of the center of the area of interest are listed. And if we click on one of those areas of interest, we zoom right into that in the image, so we don't have to kind of do that analysis ourselves and look back and forth and try to figure out where the little green circle is in the image. We can just click on those and go directly to them. For navigating between the images, we can either use our buttons down here to move to the previous and next image. We can enter a specific image number in the box here, or we can use keyboard shortcuts. Again, the left and right arrows will go ahead and move us to the previous and next image. You can also use the thumbnails down here at the bottom and scroll through those and click on any given image, and that will take you directly to that in the image set as well. Down at the very bottom here in the status bar, we have some additional information about the image itself. We have the GPS coordinates of the drone when the image was taken. We have the relative altitude of the drone when the image was taken, relative from where the drone took off, the drone's orientation, as well as the estimated average ground sampling distance. So that tells us how much ground each individual pixel represents in the image. I am going to stop there for this algorithm. We'll talk about the actual process of how we run through these in one of the other algorithms. So I'm going to go ahead and close that out. And let's go ahead and look at the match filter algorithm. So match filter, still in that color match section here. So no, we're not using thermal. No, we're not looking for people specifically. Do we have a specific color we're looking for? Yes. Okay, we're over here. Do you want to directly control the color range? No. We don't want to specifically control the color range. Let's use the match filter algorithm. So the way match filter works, we select our color, and then all we do is specify a threshold, and that's basically how close to that color does it need to be for it to be considered within or close enough to be a match. We can use our view range again, and we can see it's a different shape over here of colors that it considers to be in range. And from there, the process is virtually the same. We still hit start, it runs through all the images, and we go into the results viewer. Before we move on from our color match algorithms, the reasonable question is, well, how do we know which color to pick to start with? There's a few ways we can go about this. You can go ahead and just pick something using the color selector here. If we know somebody was wearing blue jeans, we can come over to this website or a website like this, and it provides different hex code values for different types of denim, and we can select one that's in line with what the person was wearing and go from there. Or we can, I'm by no means affiliated with a company that makes these and don't have affiliate links with Amazon or anything like that, but one option that we've started to explore is using these little felt tiles. So they're 12 inches by 12 inches, and there's a good picture. And you see it basically represents the whole range of colors, and thought being that we can take these out to the site with us the day that we are flying. We pick the one that best represents what we know the person was wearing. We go ahead and put it on the ground, and we have the drone take a picture of that as the first picture. And then through whatever image editing software you prefer, you can use the eyedropper and pick a color from that section of the photo that you took with the drone and use that as your base color for doing the color match. So options to consider as you're using the color match algorithms. Moving on, let's say we go back up here. Let's still not look at thermal quite yet. Are we looking for a specific color? Let's say now the answer is no. We don't know what the person was wearing. So we're left with just being able to look for anything that is anomalous in the image. And then it comes down to this decision point, is the background of the image complex? So in a lot of instances, we'll be in scenarios where it's, a urban wilderness interface where there's a lot going on in the images, or just a mixed environment, and there's going to be a lot of background noise in the images, and that comes into the images and affects how the images are processed by the algorithms, because these two algorithms, MRMAP and RX anomaly, work by trying to identify anything color-wise that doesn't make sense in an image. Well, if you're in an image that is all over the rainbow color-wise, it's going to have a really hard time to decide what is actually anomalous or not. And the MRMAP algorithm does a better job of being able to filter out that noise, and specifically work in environments with much noisier backgrounds. So back over to ADIAT, I'm going to switch data sets. So let's go over to this one. And these weren't handpicked for these particular use cases. We're not gaming the system here. It's more interesting to have different imagery to use for the different runs of this. So we go ahead and set that. We set our output directory, and let's go ahead and use MRMAP for this one. Now MRMAP, the way it works, again, it is much more aggressive. So I'm going to increase our min object area from 10 pixels to 100 pixels. We set our parameters here, image segments. So this is, do we want to divide the image into sub-images rather than look at the entirety of the image, just compare the pixel to the pixels that are closer to it in the image. Window size, that's kind of a proximity thing of how close does an anomalous pixel need to be to other anomalous pixels to be considered part of the same anomaly. And then finally a threshold, which is basically a sensitivity. I'm going to leave those right where they are and go ahead and run the MRMAP algorithm. And this is going to run on 321 images, so I will spare you watching this scroll and come back when it is done. All right, our MR map algorithm has finished running. We looked at 321 images in 61 seconds, so about 5 per second. Certainly not as quick as the color match algorithm, just something to consider. It's just a more complex process to identify these anomalies. The timing is pretty similar with the RX anomaly detector. You will notice that out of 321, it didn't eliminate that many. It eliminated 9 of them. And that's just something you're going to have to be willing to accept with these anomaly detectors. It's going to find a lot of stuff that doesn't make sense in the image that isn't necessarily what you are looking for at that time. Now, the good news is, as we go into the viewer here, yes, it will find anomalies that aren't interesting to us. So like this, a lot of stuff in this parking lot. But the good news is I don't have to search through the entire image myself to make that determination. More often than not, especially when I'm using either of the anomaly detectors, my focus is over here on the right side, really just looking at the thumbnails, and I can quickly go image by image, scrolling through the thumbnails to see if there's anything of interest in there. So we saw that first one, nope. Second one, nope. And I will literally just go through them. And if there's more than fit on the screen, quick thumb scroll or mouse scroll, and I can move on to the next one. So as you can tell, I don't spend a lot of time on any individual image. Hopefully this is coming through in the recording. It's not too jumpy. But I can usually go through them and make the decision within maybe a second that there is or is not anything of interest in that image, and we can move on to the next one. And I am just going image by image and clicking the next button. I can also press the down arrow, and you see down here it goes ahead and grays it out, and that way, well, I really should have been doing that with all the previous ones, but that will skip that image going forward. So I'm going to keep going. None of these are of interest to me. I'm not seeing anything that I'm looking for. I know I'm looking for a person specifically, so I keep going. So we do see some debris here. So if we want to, we can click on that and see what it looks like in the image. Okay, we may flag that one or leave that one that may be of interest to us. We'll go ahead and leave that one too. We see the same item there. We see something going on here, so let's go ahead and leave that one. That looks like just trash, so we'll go ahead and cull that one, back to the parking lot, parking lot, parking lot, parking lot. Just going through, see something interesting, go ahead and click on it, see if we can identify what it is. We'll leave it in the set. There's our green thing again. Okay, there we go. We found our subject. So yes, you're clicking through a lot more images in this process, but you can see, as you can tell, it's going to find anything of interest. And if you are in a scenario where you don't know what the person is wearing, it's a great option. And yes, this is a dummy. I am not using images from a live search. So we've identified our person there. Let's see what other images have the same dummy in them. So yes, 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 there's our dummy. I'm going to go ahead and cull these. And I'm actually going to pause here, and I'm going to finish culling these just in the interest of time. All right, we're back. I finished culling through the rest of the images. I went ahead and eliminated 299 of 312 that the system flagged. Again, that seems like a lot. Honestly, it took, well, you can see the system clocks here, but it took maybe 5 minutes to go through all those images. Even worst case scenario, let's say it took 10 minutes, plus it took a minute for the algorithm to run. So in 11 minutes, we processed 324 total images. So what, about 2 seconds per image? Pretty darn good, all things considered, even if you do have to go through and cull those images yourself. So now that we have this down to a reasonable size list of images and everything else has been hidden, obviously, as we saw, there was a pretty obvious find in this image set, but let's say we wanted to provide a report to the responding agency or to our teams in the field and give them the information so that they can go out and ground truth some of these things. So we can go ahead and use some of our exports up here. We'll start with the PDF. This generates a report for us. And you'll see when that completes. That will give us all the information about the algorithm settings as they were when this was run, as well as an actual report showing us the images that we kept, that meta information about the location, altitude, all that stuff, and the areas of interest in here as well. So it just creates a nice single file report that we can provide to the search teams or the agencies. Say, hey, here's the areas of interest that were identified. It's probably worth sending someone out to go ahead and look at these to verify what they are or are not. Make that process even easier, we can go ahead and click our map balloon icon here, and this will call it map. This will create a KML file for us with the locations of the drone when those images that are still in the set, that is ones that have not been hidden, flagged. So this shows us exactly where the drone was when those images were taken. Lastly, we have the zip output, and this is just to collect just the images that have not been hidden. So as I mentioned at the beginning, when we look at our folder structure here, the output is going to have all those augmented photos in it. So what we're doing with the zip export here is getting rid of the noise, getting rid of the ones that we've decided to hide, and only zipping up the ones that are still being shown in the viewer here. So we can include that in our work products as well. Moving on to the last of the non-thermal algorithms here, and that is the person detector. So are we using thermal images? No. Do you want to focus exclusively on detecting people? Yes. So let's use the AI person detector. So going back into ADIAT, we'll go ahead and select the AI person detector algorithm. And this is taking a couple seconds because it is checking and verifying that the computer is set up to leverage the GPU to run this model as efficiently as possible. As we mentioned in the previous video, AI is still pretty darn hard on even modern computers. So there's some things we can do by utilizing the graphics processing unit to be way more efficient and run this algorithm faster than if it was just relying on the CPU. Now the trade-off is the setup process for using the GPU is a little more complex and requires a little bit of work ahead of time. So not required, and we provide some information about how to do that setup, but what we're doing here is just giving the user one more check to say, hey, just letting you know, we have verified that we are going to be able to use your GPU for this process, and it's going to go pretty fast. So let's choose our last RGB image set here. And our only parameter is confidence threshold. How confident does the AI algorithm need to be that what it's seeing is actually a person? I'm going to go ahead and leave this at 50 for now. Min object area, I'm going to leave at 100 because we're specifically looking for people and we don't want anything too small. So we'll go ahead and start that. And it's skipping a couple files, so ADIAT will automatically skip things that it can't process. So in this case, I forgot I had some zip files in there, so I went ahead and skipped those, thankfully, and it starts going through the actual images. Again, this takes a little longer, certainly longer than the color match algorithm, so I will pause the video here and come back when it finishes running. Our algorithm finished processing. We processed 234 images in 87 seconds, and 35 had areas of interest where we were specifically looking for people. The speed is probably about as much as you could possibly hope for at this point. This particular computer is pretty well equipped with the latest and greatest, so use that as a benchmark for 234 images. 87 seconds, and these are 48 megapixel pictures, so that does come into play as well. So we'll go into our results viewer, and we've already looked at all the features of the viewer, so we will just scroll through. Yes, we do still see some of these false positives like we do with the anomaly detector. We can go ahead and knock those out, and then you see fairly quickly we start to get into images where it does correctly identify a person. With that, we can go ahead and move on to the thermal algorithms. So back over to our decision tree here. Are we using thermal images? Well, the answer is yes now. Are you looking for anomalies in a specific temperature range, yes or no? Let's go ahead and say no. I don't know the actual temperature range of what I'm looking for. I just want to find anything in the image that doesn't belong. Very similar to our RGB algorithms over here that are just looking for color anomalies. The temperature anomaly detector is looking for thermal anomalies. Back over in ADIAT once again, we'll go ahead and select the temperature anomaly algorithm. I've already set up the input and output folders here. Let's look at some of the parameters. So anomaly type, are we looking for things that are hotter or colder than the rest of the image? I'm going to leave it as above or below mean, so both hot and colder than everything else. Anomaly threshold, that's how many standard deviations away from the mean temperature in the image must something be to be considered anomalous. Color map, that's what sort of coloration do we want to apply to the thermal data. We can do white hot, black hot, or any of 3 different colorations. We'll leave it as white hot. And finally, image segments. Much like with the color anomaly detectors, we have the ability to slice the image into smaller pieces and only compare the pixel to that slice instead of the whole image. So we'll leave all those as is. Go ahead and run our algorithm. And we're only looking at 2 files here. So let's go ahead and go into the results viewer, and we can see everything that it found to be anomalous. Now, this is sample data from DJI, so it doesn't have a lot of the metadata like the GPS information, but you will see down in the status bar that we do track the temperature for any given pixel as you move around the image. So we can see, compared to the surroundings or compared to other pixels in the image, why something was flagged as anomalous. That concludes the look at all of the different algorithms in ADIAT. A couple other features to look at really quick. Up here in the menu, load file, that allows us to load a previously run, a previous run of ADIAT. So for example, if we go all the way back to our color match, we can go to our output directory and find that XML file. And you'll see it pre-populates it with all the information as it was when this was originally run, and we can go directly to the results viewer. We don't have to rerun the algorithm and go through that whole process again. We also have our preferences here. This allows you to change the coloration of the interface, light or dark, max areas of interest. So this is a safeguard that's in there. Every once in a while you'll run into a scenario where, especially with the color range algorithms, you set the color range to something that includes all the super dark colors or all the white colors, basically all the highlights and shadows, one or the other. And the result of that is you end up with a slew of things that are identified as areas of interest. This is just a little safeguard, as I said, where if it goes above a certain number of areas of interest, it pops a message up on the screen saying, hey, do you want to continue? There's probably a ton of false positives here, and you might want to reevaluate the algorithm parameters before continuing. Area of interest circle radius. This is just talking about how much buffer do we want around the area of interest for the identifier circle. Coordinate systems, we can do that long with decimal degrees, minutes, seconds, or UTM, temperature units, distance units, and a drone sensor file. So this comes into play with some of our calculations, especially GSD. Every once in a while, new drones come out, and we need to account for those in our data dictionary. So if a new file becomes available, we'll post that to the website, and you can grab it from there and replace the old file without having to download a whole new version of ADIAT. So there we have it, folks. We have our algorithm selection guide going through that decision tree, trying to decide which algorithm best suits our needs. We've looked at the ADIAT interface. Thank you again for your time, and if you have any questions, by all means, feel free to reach out. Thank you.